In this question, a triathlon organizer has ordered 600 meters of fencing for the transition zone for bikes and men's and women's changing areas. She wants to set up the fencing as shown in the diagram. What should the outside dimensions be in order to maximize the available area inside? To solve this question, we first need to come up with a function for the perimeter. In this case, notice that we have 5x lengths and 6y lengths, so therefore our perimeter is equal to 5x plus 6y. We know that the perimeter is equal to 600, so that can be substituted in for p. And now we need to isolate for one of our variables. Let's isolate for y. When we do that, we'll subtract 5x from both sides such that we have the following. And now we'll divide by 6, such that we have y is equal to 100 minus 56x. Now we need to come up with a function for the area. Notice that the length going across the top and the length going across the side would make 2x, all multiplied by 2y. We multiply these together and simplify, we have 4xy. Now from here we can take our function, our perimeter function, and substitute inside, such that we would have 4x, all multiplied by 100 minus 56x. Now if we distribute the 4x across our two terms, we have negative 10x squared all over 3. That has been simplified from negative 20 over 6, which we would have had right here. And 4x times 100 is positive 400x. We're now ready to go ahead and complete our square. If we complete the square, we'll be able to find out our maximum area. In addition, we'll be able to find out our two dimensions. First, we'll start by factoring out negative 10 thirds. When we do so, we're left with x squared minus 120x in the brackets. From here, we'll take 120, divide it in half, and then square it, such that we have 3600 minus 3600. Now we'll take the negative 3600, it'll get multiplied by our leading coefficient a, and we have 12,000. Now we're ready to go and complete the square. We'll take x squared minus 120x plus 3600, and we have x minus 60 all squared. This tells us that our maximum area will be 12,000, and the dimension for x will be 60. Because we know the dimension for x is 60, we can substitute that into our function for y to determine what y is. When we do so, we have 100 minus 5 times 60, which is 300. 300 divided by 6 is 50, so 100 minus 50 tells us our dimension of y is equal to 50. Finally, let's check our solutions. We have a maximum area of 12,000 meters squared and dimensions of 100 meters by 120 meters. And we are correct.